Hi there. We'll be talking about Prim's algorithms today. Prim's algorithms is the second strategy we would be studying for finding our MSTs. In the last video, we talked about cruise cows, where we started by listing all the vertices, forming an empty graph, and then attaching the edges starting from the cheapest, which does not form a cycle. The Prim's algorithm is almost like the Kruskals algorithm. The only difference is that we are going to be starting with a fixed vertex instead. In the Kruskals algorithm, we started with an empty graph. We listed all vertices with no edges. Then we started to attach the edge from the cheapest that does not form a cycle. But in Prim's algorithm, we start from only one vertex. We'll call that a fixed vertex. So we start from a fixed vertex and then we grow the tree. And in every step, we are going to add a vertex that is not already attached with the partial tree and that also has a minimum width. So let's get started. We are going to be using this graph just like we used for the Kruskals algorithm. So let's start finding our MSTs, but in this case, using the Prim's algorithm, we start from a fixed vertex. Let's start from, let's say B. We start from a fixed vertex, let's say B, and then we're going to grow the tree. And in every step, like I said, we're going to add a vertex that is not already attached to the partial tree. So we could add C here. And the weight is minimum, it's 1. Which other vertex can we add? We can quickly add D. From C to D is 2. We can add BD would form a cycle with CD and BC, so we don't add that. So we can add vertex A, and let's see, the cheapest to add is from A to D, which is 8. So the next vertex we can add, let's say that we add F. Let's add F, and we can go from C to F, which has weight 4. And we then add E, which is of course the last vertex, and we have from F to E, which is the cheapest, 5. We could add from C to E, but C to E costs 7, E to F costs 5. So this E to F is the cheapest. So this is our MST. It's a minimum spanning tree. And one thing I love for us to notice is that whether we find our MSTs using the Kruskals algorithm or the Prim's algorithm, we are going to be getting an MST that has exactly the same cost. For example, in our Kruskals algorithm, the cost of our MST, of the MST we got, is exactly the same with the cost of the MST we have gotten in this example using the same graph. So whether you use the Kruskals algorithm or you use the Prim's algorithm or the reverse delete algorithm, which we are going to be looking at in the next 2 videos, you're going to have an MST that has the same costs, number of, even if the MSTs might be different, it's possible to get different MSTs, but the cost is going to be the same. That's just what I'm saying. So I'll see you in the next video where we are going to be talking about the proof by cut property, which we use for proving the Prim's algorithm and the Kruskals algorithm. Let's meet up on the next one.